Alright, well we made it to our last intro video, 12.3 day 3. Let's take a look at a couple things as a review. All students take calculus, so hopefully we talked about this in class. All students take calculus. As a reminder, what this means is that all your trig functions are positive in the first quadrant. In the second quadrant, your sine functions are positive, and that means sine and cosecant because those are together. In the third quadrant, the tangent function is positive, and that's tangent and cotangent. And then in the fourth quadrant, your cosine is positive, and that's cosine and secant. So all students take calculus. That's just a nice little acronym to help you remember which trig functions are positive in each quadrant. That means that if sine and cosecant are positive in the second quadrant, the rest of them are negative. In the third quadrant, tangent and cotangent are positive, the rest are negative. And in the fourth quadrant, cosine and secant are positive, the rest are negative. And in the first quadrant, none of them are negative because they are all positive. And then just a reminder about your reference angles. That's where we connect to the x-axis. Your reference angle is right there. You have a positive x, positive y, and then your r value over there. If your reference angle is in the fourth quadrant, you have a positive x but a negative y. If you're in the second quadrant, connect to the x-axis. You have a negative x value and a positive y. And remember, your r value is always positive, that hypotenuse. And if you're in the third quadrant, you have a negative x and a negative y. And so your reference angles are here at the origin, connecting you to the x-axis. Alright, so our directions in our first three questions ask us to write as a function of an acute angle. So all of your reference angles are acute angles, all these reference angles. So what we're going to do is we're going to draw our angle like we always do. We're going to identify the reference angle, and then we're going to write it as a function of that angle. So let me show you how this works with our example. So tangent of 281 degrees, that's positive. So I know I've got 90, 180, here's 270, here's 360. So I am going past 270. And then to get to 270 to 281 is just 11 more degrees, so just a little bit into this quadrant. Alright, so what we need is the reference angle. So we connect to the x-axis. To figure out what this is, we're going to take the value at the x-axis, 360, subtract out our angle, 281, and that's going to give us 79 degrees. So the acute angle is going to be the 79 degrees. So we're going to say tangent of 79 degrees. However, what we want to figure out is your tangent positive or negative in this quadrant? So in the fourth quadrant, let's see, all students take calculus. Cosine is positive in this quadrant, which means tangent must be negative. So we're going to put a negative in front of our tangent. So negative tangent of 79 degrees. This has the same value as tangent of 281 degrees. It's just one is in, we need this one because they asked for an acute angle. Alright, secant of 132.4. So again, we start out by drawing that out. It's positive, so I'm going to go up 90, 180. So it's between 90 and 180. So I'm going to go 90, and then how many more degrees to get to 132.4? Well, we can subtract. Take the value from the x-axis, so 180 minus 132.4. What that actually is going to give us the reference angle of 47.6 degrees. What that means is my angle is going to land 47.6 degrees off of the x-axis. So that's about halfway. It's just past halfway. So I'm going to, there's the angle. again, we want the reference angle. Well, we already found it. I found it in an attempt to help me know where to graph that. So this is 47.6 degrees. So we need to know if secant is positive or negative in the second quadrant. So all students take calculus. So sine and cosecant are positive in the second quadrant, which means secant must be negative. So our final answer is a negative secant of 47.6 degrees. All right, last one of this type of problem. Cosecant of negative 124, so we go ahead and we draw that out. Negative means we're going negative 90, negative 180, so it's got to be between those two, so I know I'm going to go this far. And then to get from 90 to 124, how much further do we go? Well, that's going to be 34 more degrees. So just about a third, just past a third of the way. All right, our reference angle, the one we need, because we need an acute angle, connects us to the x-axis. To find that, you take your x-axis angle, 180 minus 124, and that's going to give us 56 degrees. All right, so our answer is cosecant of 56 degrees, but the question is, should that be a positive or negative? So that's where we use our little all students, to think about it for a second, take calculus. So we're in the third quadrant, so tangent and cotangent are positive, which means everything else is negative. So that means cosecant will be negative, so we throw a negative onto that answer. All right, for this last example, we're going to do a little reviewing from trigonometry and geometry and special right triangles. So hopefully you guys remember 45, 45, 90, sounds familiar, 30, 60, 90, 30, 60, 90. So if you have a 45, 45, 90, and theta is your 45 degree angle, our three sides will be the same every single time. You're going to have a 1, 1, square root of 2. All right. For a 30, 60, 90 triangle, if theta is the 60 degree angle, across from, so that makes this the 30. What I always remember is across from the 30 is the 1. Your hypotenuse is always 2, and across from the 60 is the square root of 3. And then if your angle, if theta is the 30 degree angle, across from that is the 1. Across from the 60 is square root of 3, and your hypotenuse is always 2. So start looking those over. Remember those. That really helps us out when we have to find the exact value of the 6 trig functions for each value. So here's how we do this, is we draw out 300 degrees. So that's 90, 180, 270, 360. So it's going to be into the fourth quadrant, and in the fourth quadrant we are going to go, let's see, we're at 270, we have to get to 300, so we're just going to go 30 more degrees. We want our reference angle right here, so we're at 300, so maybe we would say, oh yeah, well that reference angle is 60 degrees. If we weren't sure how to get that, you take your x-axis angle, 360 minus 300, and that's how you get your 60 degree reference angle. So what we are going to do is we are going to evaluate our 6 trig functions for 60 degrees. And guess what? We have a 30, 60, 90 triangle that we're going to use. So when we go ahead and in our triangle we connect it to the x-axis, well, this is getting really sloppy now. This is 60 degrees at the origin. The hypotenuse for a 30, 60, 90 is always 2. Across from the 60 is root 3, and across from 30 is 1. So I just made that really sloppy. I'm going to go ahead and just quick sketch that again down here. Basically what we have is, this will be a little bit neater. This is a 60 degree angle, that's our reference angle. our hypotenuse is 2, across from the 60 is square root of 3, and across from the 30 is a 1. Now in a coordinate plane, remember these have signs. If you go to the right, it's a positive 1. If you go down, it's going to be a negative square root of 3, and then your hypotenuse is always positive. So we can go ahead and evaluate our 6 trig functions, because if we were to do sine of 300 degrees, sine of 60 degrees with the appropriate positive or negative signs, because it's the same terminal side, will give us the same values. So sine of our angle is going to be opposite over hypotenuse, so negative square root of 3 over 2. Cosine is going to be adjacent over hypotenuse, 1 over 2. Tangent is going to be opposite over adjacent, so square root of 3 over 2. Alright, cosecant is the reciprocal, so negative 2 over square root of 3, but then we have to rationalize, so we get negative 2 root 3 over 3. Secant is our reciprocal of cosine, so 2 over 1, or 2. And then cotangent is, we flip 2 over root 3, rationalize, we just did something similar up there with cosecant, so we could certainly look at that work. 2 square root of 3 over 3. Alright, well those are our 6 trig functions. We knew it was a 60-degree reference angle, but without knowing anything about your 3 sides, if it's a special right triangle, we can go ahead and fill in our 3 sides, which allows us to evaluate our 6 trig functions. So that just kind of ties it all together right there. Oh, there's our next example. Alright, so negative 45 degrees is going to go down 45 degrees. That is going to be exactly halfway. So I'm going to connect to the x-axis. It has a 45-degree reference angle. So if we remember how to label our 45-degree triangles, your 2 sides are 1 and 1, and your hypotenuse is square root of 2. Again, keep in mind your sides, it's a positive 1 to the right, it is a negative 1 going down, and your hypotenuse is square root of 2. So again, those 3 sides I'm just getting from our special right triangle over here. So if your reference angle is a 30-degree angle, a 60-degree angle, or a 45-degree angle, then you just plug in your sides from your special right triangles. Alright, well we can go ahead and evaluate. Sine is going to be opposite over hypotenuse, or y over r, negative 1 over square root of 2. We need to go ahead and rationalize that, so we get a negative square root of 2 over 2. Cosine is adjacent over hypotenuse, or x over r. Oh, we're going to have to rationalize that also, so that's a positive square root of 2 over 2. Tangent is opposite over adjacent, or y over x, giving us a negative 1. Alright, we can go ahead and fill in, or find our reciprocal functions. Sine and cosecant are reciprocals, so I'm going to go ahead and flip the original one there. Square root of 2 over a negative 1 is just a negative square root of 2. Secant of our angle is square root of 2 over 1, or just square root of 2. And cotangent is 1 over negative 1, still a negative 1. And there you have your 6 trig functions from an angle that had a reference angle that came from a special right triangle. So there you go for kind of a long intro video to end out Algebra 2. Alright, so here's your last Name That Tune. Going back to 1996, the year I graduated from high school, and this was a pretty big song my senior year.